Welcome to Copper's Bright New Age, a video series that celebrates the large volumes of copper being used in the fastest-growing energy technologies of our time. Clean tech growth is building huge momentum. It saves us all money, and it will help solve our climate change and energy supply problems. As renewables become our dominant energy solution, clean technologies that are expected to grow significantly during the 21st century include geothermal heating and cooling and direct exchange geothermal. Called DX for short, direct exchange is among the most efficient and promising technologies on Earth. It produces about 4 or 5 units of heating or cooling for every 1 unit of energy it uses. A regular gas furnace delivers less than 1 for 1.
Geothermal technology is rapidly advancing. We're working on projects all over the world. At one time, geothermal was considered a luxury, but costs are becoming competitive, and government incentives and more financing options are helping to make direct exchange geothermal a popular heating and cooling choice.
We did Geo in 1, and once people saw it and were made aware that this is actually available, that I can save money, every single other house got it. I think we'll do all 17 houses. This one costs $100 a month to heat. These ones cost $400 a month to heat. My mortgage is $30 more a month. My out-of-pocket is $270 less per month, right out the gate.
Well, copper, due to its thermal properties and its molecular characteristics, it is very conductive of heat transfer. What we know about copper in comparison to high-density polyethylene, your standard HDPE piping out there, you're about 100% more efficient. You're just adding at an exponential level the amount of efficiency to the system with very minimal energy input. Your typical fossil fuel systems have operating efficiencies ranging from 86% for a brand new oil-fired system to upwards of 96% for maybe a high-efficient condensing boiler or gas furnace. Geothermal efficiencies, based upon their COPs, they're operating around 400. We could just say 400% efficient in the transfer of energy.
Drilling can now be done with small machines, which can get into many tight spaces without damaging buildings and landscaping. Once drilling is done, the copper lines are fed into the drill holes and insulated with a special conductive grout. Then the copper lines are connected to the building's mechanical system through a geopump, which concentrates heat from below ground in winter or cooling from below ground in summer. At first I worried about the copper, but in fact it's a real advantage. It's super conductive and reliable. I'm familiar with it and I have total control. In the ground it's encapsulated with grout and protected by a system comparable to the best municipal infrastructure. If you do it right, it will work perfectly for a long, long time.
DX systems operate at higher pressure levels and thus require copper tubing. Type L copper tubing offers ratings that are 5 or 6 times higher than, for example, PEX and CPVC. Leading standards authorities, ASHRAE, CSA, UL, ULC, and governments in the USA and Canada have recently recognized copper DX geothermal systems, and they are strengthening regulations around other modern geothermal technologies and drilling. The recognition has built momentum behind a DX revival that had already been underway because of recent technological advances. DX Geothermal, another success story for copper's bright new age.